second derivative test. The assignment is up there. Make certain you read the material. I don't have time to go over all the little details, and so page 232 through 241, much of that's going to take a couple readings. But I'll try to hit the high points on that today as we're going through this.
This policy.
Yeah, she'll be coming. I want to review with you just a little bit of what we're doing in Algebra 2 right now, because it comes into play in some of the things we do. Let's go with this equation, y equals x minus 1 all over x plus 2 times x minus 3, like that. Okay? Now, some things that I want. I'd like to have a graph of that without using a calculator. Much of what we're going to do, we're going to try to think this stuff through without calculators. Okay? Now, first off, I'm going to write it this way because it can be helpful. Okay? Now, what is the y-intercept?
1/6.
That's when the y-intercept is when x equals 0, and someone said that's going to be y equals 1/6. That's going to be 0, that's a 0, that's a 0, so it's a minus 1 over negative 6. Okay, now, what is the x-intercept?
Y equals 0.
That's going to be 1. That's when y equals 0, and so the numerator is going to be x equals 1.
Can I go get my calculator?
Yep. Okay.
Asymptotes at -2 and 3.
Okay, and the vertical asymptotes are x equals a minus 2 and 3. Now, how about the horizontal ones?
X equals 1.
Somebody said 1, that is not correct. It's 0. Okay, and that's y equals 0.
Okay.
And that's because the power is down here, and all we're going to look at is this term and this term. Nothing beyond this. Okay? And so now about the graphing of this thing. So you get an idea of a quick graph of the function. We have an x-intercept at 1. That'll be right over here. That means if we're on this side, we can pass through it, or if we're on the other side, we can go through it that way. That's the only place you can go through the axis here, the y-axis. That's the only intercept that we have. Okay? And this point right here is 1/6. And then we have the asymptotes, which would be at 3. We'll do this one over here like this, 3 this way, and then at a minus 2 over here. Okay. This is what they had a test on. They're going to have another test on next week, Tuesday, on doing a number of these. Okay, now, you told me there was a horizontal asymptote at 0. So way out here, it's going to approach 0. Is it going to approach 0 from the top side or the bottom side?
Top.
It's going to be the top because, this is the reason, this number is going to be very large. So that's going to be very large minus 1, that's just still very large, okay? And this one is going to be very large plus 2, and this is going to be minus 3. So we have something very large, very large, very large. All of them are positive, so it's positive. Well, very large at the bottom, but it's going to be very close to 0. So we're over here. Okay, now I'd like to talk about this side. This is going to be very large negative. Okay, so that number's negative, that number's negative, and that number's negative. 3 negatives make a
Negative.
So I'm on the bottom side. So that's where I have to end. I'm going to start here. Now this is how this thing goes. I have to keep going from right to left. Can't stop, ever. Unless I hit infinity. Okay? So I'm going to go this way. I cannot, there are no passageways here. and I get closer and closer here, so I'm going to go like this. Okay, now I'm keep going, and I'm going over to the left. I continue to go to the left forever. Closer and closer to that asymptote. Okay? But now, I quit that, and then it comes back on this side, like this. Okay?
Yep.
And unless it's a squared thing, we've talked about that. Now, here's my passing wave. I have to go through here. And I have to hit this by coming this way. Okay? And then I have to get around the corner, and I have to go to that point. And now, there are no passageways down here, so I have to keep on going like this, and then I go this way infinitely far. Okay? And come back on this side, over here, and then I approach this point over here. See? There's the graph.
You don't come from the top?
No.
Okay.
You only come to the top if this here unit here would be squared.
Okay.
That's like this. Y equals 1 over x plus 2 quantity squared. Like that. See, that graph would look like this. Asymptote at a -2 like this. And it would go like this way, and come back down this way. Okay? Just a quick review on that stuff. We haven't done this very long in Algebra 2. It's a rather new one because we've got so many things going for us with graphing that becomes more and more important. I find Desmos really working well to do this graphic. And so, that one. Now, a few things about today. First off, in this chapter, this section 4.2, on page 233. Now, what I have up here is a little bit different in your book. I tried to write it carefully, so I hope I didn't make any mistakes. And I think some of what I did is a little more descriptive. What he has is good, okay? Now, this is the first theorem that he has in there. And it says, let f be a continuous function on the interval AB. He says I, okay? But I do it this way because it's on the open interval, okay? And let f be differentiable on that open interval, okay? Then, on that interval, if f prime at x is greater than 0 for all x in that interval, every point in that interval, then f is increasing in that interval, okay? That means something like this. We have a little interval here from A to B, and all the slopes are up. See? Okay. Like that. That's all it means. Okay? And this one says if they're negative, then it's going to be a decreasing function.
Makes sense.
Okay? Stuff that you kind of know already. So, but it is quite important stuff in terms of making quick judgments when you see this. If you find the first derivative being a positive value, then it's going to be increasing. Okay? Now, here's the first derivative test, and this is how I want you to do problems 26 and 29. There'll be some more coming later. And when I say a table, the table is going to look like that. Okay? I find these so helpful. I wish this book did it that way. I got this idea from a book by the author of Larson, this makes it very, very easy to follow, and you'll see that in two of them that I would do today. Okay? Now, this is the first derivative test, and that's on page 236 in your book. And this is what it says. If f is, let f be continuous on an interval, AB. Again, notice this is an open interval. Pretty soon I'll have one that's closed. In which C is what? Is the only critical point. C is the only critical point in that interval. Very important to know that. Okay? And f is differentiable on the interval, except possibly at C. And my second illustration is going to be one where it's not going to be differentiable at C. Okay? Your book uses a little bit different word there, but it basically means the same thing. Okay? Number one, on that interval, open interval, if f prime at x is greater than 0, that means it's positive. Are you with me here? To the left, okay, here's C. and this is C, and that's the point right here, and to the left of it, it's positive, like that. See, this isn't going to be very hard if you just watch along here. And it's going to be negative on the right. It's going downhill there. So what do you think this is?
A local max.
Local maximum, okay? And you might find me using relative because I have used that more often than local, but either one is fine. Yes?
Why couldn't it be a absolute maximum?
Okay, now,
Could it?
no. Well, yes, it could. It could. It could. It's in yesterday's assignment. We talked about it a little bit this morning too. When we're looking at absolutes, then we look at endpoints. But this thing, you notice there are open intervals, so this point here will not happen to be on the end. It's important for the discussion here. This could be the absolute too, or the global.
It could be.
It
but
could.
If it keeps going down, it could be the absolute, but we don't know.
We don't know. Okay, and I believe you had to do. Did you have to do some of those today? Yeah, you had to find them. The procedure. You looked at all of them, and then the biggest one. Okay, good point. Thanks. Okay, now look at the other one. On the interval AB again. If you have the other thing happening, if f prime at x, first derivative, is, and its value through all those c points there, is negative to the left of c, that means this way, it's negative here. Now we have c over here like this, it's down, going down. And then on the other side, it's going up. That's going to be a relative min. Now that takes a lot of writing and stuff to get that clear. But we're playing with some pretty powerful stuff. So that's important. Okay, now, what's this? If f does not change signs at c, then f at c is not a local extremal or max or min. Now, how does that happen? Now, working with you guys on that, that happens like this. It's going up like this, and then it turns and goes like this. Okay? Now, it's going to be 0 there. See?
Right.
And here's going up, and it's up here. Both of these, it's up on both sides. Okay? Questions on that? See, this is point C. Yes?
So that is a critical point then?
This here is a critical point?
Yeah.
Yes, it is.
But not an extreme.
Okay, what is a critical point? Let's go, let's all have that once again. A critical point is one of two things.
F of C, F prime.
Jeff?
They said no, F prime of C doesn't exist.
F prime at C does not exist, and F prime at C equals 0. Okay? Okay? So it is, and that's where, were you here yesterday? Oh, we had a good discussion on necessary and sufficient, and we had a video, and I told, the kids were thinking it was funny watching me as a teacher, and I thought it was funny watching the kids say, yeah, I get it, and they didn't get it. Pardon?
Can we watch it again since so many people are done?
No, okay, now, here we go. Watch what happens with this little grid I made. What we do is this. I'm going to build on it tomorrow a little bit more. And what I'm going to build on tomorrow, dealing with concavity. Concave up and concave down. Okay, now, I'm going to start with this problem. This is really a nice, easy one. It's a third degree. And you notice this is positive, so it's going to be an equation function that's going to look like that. Okay? It's a third degree with a positive over here, and you should know this. Okay? So we're going to expect a max here, a min here. Okay? Now, that's just playing with some things to make life easier. Now, first thing I'm going to do is find the first derivative to find the
Slope.
no
Heck.
critical points. Okay, find the critical points. So this is going to be like this. I think we're doing all right. Okay, and then we're going to make this 6 times x.
Can you take a 6x? And then I see.
I know, there's not x here. And so this becomes See that?
C.
Are you with me?
Yeah.
Guys back there? Now, that's a little bit why I was doing that little bit of work in the beginning. Now, notice here, we have two places where now I would like to make this equal to 0. So f prime at x equals 0 when x is equal to
Negative 2 and 3.
-2 and 3. So those are the critical points. And what I do with this, and now this isn't how Larson necessarily does it, but I do it this way because I think it becomes so easy. I put my first one down here and I put them in ascending order. I put a -2 here and a 3 here. Okay, now, what I'm going to do next is have the interval. Now, what I'm talking about in terms of intervals here, this one starts because you notice this is defined for all, this domain is all x. Okay? I can put any x in here. So this is going to go from -infinity is less than x is less than a -2. That's the interval I'm taking. So graphically, see this at this point where it's really going to turn out to be that it's -2. So I'm taking everything from this side over here. Okay, and this just keeps coming up here. And I'm taking everything up to there. And then this one is going to be from a -2 is less than x is less than 3. And this one is going to be from 3 is less than x is less than infinity. Now, notice some of you would prefer to write this way. This is just x is greater than 3. And here x is less than a -2. These two things there. Any question on that?
You can do that?
Oh, yes.
Okay.
But I wanted to put it this way. You could also do it another way. In fact, I will move this down pretty soon. I'll just, we'll just do this one. This could also be written this way. 3 infinity like this. That could also be. Notice 3 ways to write that. Okay? Now, the next thing I would like to do is a test value. Hope you're listening, because the book doesn't goes into that very much. What is the nicest point in this interval to work with?
Middle one.
1, right?
Yeah.
I can even improve on that.
0.
We can go 0.
I like that idea.
Okay? It's just 1 point in here, because the behavior of the first derivative in this section is all the same. They'll all be positive or all be negative or all zeros. Okay? Same here when we go over here. Okay? What's a nice point to check here? That'll work out nice.
-5.
Okay, -5. I would have chosen -3, but that's okay. What's this one?
4.
Okay, 4. Now, I'm going to evaluate the sign of this thing, this here, at this point. Okay? In other words, this is what I'm looking at right here, and I'm going to figure out its value. Okay? If I put a -5 here, and all I want to know is the sign, I don't want to know the number. If you want to do the number, go ahead. No problem at all. Put this in there, use your calculator to pick up the 3 numbers. That's a wonderful technique. But if you want to just put the numbers in here, this is a 6. This is going to be a -8. And this is going to be a negative.
3.
So it's going to be positive or negative.
Positive.
So this is going to be positive. Okay? Now, put a 0 in here. And that turns out to be, this is going to be positive, that's negative, and that's positive, right? So this is going to be negative. Okay? Now put a 4, that's positive, positive, and positive. So it's positive. Okay? Now, yes?
So if there's even one negative, it's automatically negative?
No.
No.
If you had 3 negatives, it'd still be negative.
Okay.
Okay? 2 negatives become a positive.
Because 2 negatives times.
Negative times a negative is a. Remember when you first learned that?
Yeah.
That was always kind of fun. Didn't believe it first. Okay, now the conclusion. What are the conclusions here? This is what?
Negative. Positive.
So this is going to be increasing. This one's decreasing. And this one's increasing. Okay? And then we can actually do something else. This point is going to be a what? A max or a min? This is going to be a max. local, and this is a local minimum. Are you with me on that?
Yep.
Okay, so what do you do for the max and minimum then?
Max and min? Okay, now all I have to do is draw a little picture. This one's going up. See, this is going up, and this one's coming down.
I got you.
So there's a max. See, this one's going down.
Down and then up.
Okay?
Oh,
Okay?
cool.
And do we draw it like that on our assignment?
Yes, right. And I find this is easier to interpret it and see all the information. Okay? Now, yes.
Do we need to draw it
Huh?
though? Do we need to draw it?
No, don't. But you might want to draw it just to see it, because if you draw it, it becomes ridiculously simple. Okay? And I do have it on decimals, and I'll show it to you pretty soon. I want to do another problem. And now, I was going to do that, and I don't think I have it written here. Do I? Yes, I do. This is the next one I want to do. And it goes this way. And it has a different look. It's like this. F at x equals x squared minus 4 to the 2/3. Okay? Now, to get started, let's just look at the domain. Is it defined everywhere?
No.
What x can I put in?
2. You can't.
2, that'd be 4 minus 4 is 0. And the square root of 0 squared is 0, and the cube root of 0 is 0, so that works.
It does.
Yeah, are you okay with me?
I'm fine with that.
Okay, but just so you're totally convinced, because I like to be challenged on it. Okay, and can we use a negative inside here?
Yes.
Yeah.
We actually
That'd
can.
become a problem.
Because if we take a negative in here, we're going to square it, it'd be positive, and then we take the cube root of it.
So all real numbers.
Or if you didn't want to do it that way, you can always take a cube root of a negative. So there's no problem with any of the values. Okay? Now, so we're going to spend a little time here looking at the derivative. Okay? And again, this isn't the hardest one, but what's the derivative of this?
2/3 x squared minus 4 to the negative 1/3 times
Times by
2x.
2x.
Okay? Now, that isn't a very nice look. So I'm going to make it look this way. I'm going to make 4x up here. And the bottom I'm going to have 3. And then I'm going to go x squared minus 4 to the 1/3. And I don't really like that very well either for interpretation. So we're going to go 4x like this. I'll put 3 here. And then I'll put some brackets like this over here. And I'll put 1/3 over here. And in this side here, I'll have x minus 2 and x plus 2. Okay? Now, Jeff, what are my critical points?
2 and 0.
Minus 4.
Oh, Greg already answered one of them. So the critical points,
0.
or maybe there's only one.
Oh.
It's going to be 0 right up here. Are there any others?
Minus 4.
What did you say?
Minus 4.
Minus 4. No, it's not 4. It's
2 and negative
2 and a minus 2.
4. Okay.
Why?
Because that would make the function 0. Or not work.
I'd like a little more. You're set it right. Tell me more.
They put a 0 on the bottom.
If I put a 0 here, then what happens to my first derivative?
Doesn't.
Does not
It's
exist.
broken.
Okay? So, when we look at the graph pretty soon, we're going to look at that point and see if there's a cusp. A point. Okay? And there will be, yes.
Where did the 0 come from?
Oh,
4 times 0 is 0.
right here. Okay? Again, you see a little connection by what I showed you a while ago at the very beginning, what we were doing in Algebra 2. Okay, now I have the critical points. And let's see here. Do I have another one? Let me just clean this off a minute. And then we'll fill out another little table like this. And here we go. So I'm going to put negative 2 here, 0 here, and 2 here. Now you see I just made it wide enough so if I had to do another, I just blew this up last night on Excel. And no, I didn't. I did it with Word and table. Okay, now this interval is going to be x is less than -2. Okay? This one here is going to be a -2
0.
is less than x is less than 0. I'm showing you, as I go through here, I think I'll show you 3 different ways to write this thing. Each one I'll do differently. This one, I'm just going to use the interval this way.
0 2.
Okay? You might like this better. Okay? I could have written it like this. Yes?
Okay, so like the curve brackets mean that it doesn't include that point, right? Or it does include?
I think I heard you would say it once again.
The curve brackets mean it doesn't, or doesn't?
Does not.
Yeah.
And that means, do I use that open or close?
Be open.
That's open. Okay? Got that? Now this last one, since I wrote this one this way, I will go back to writing this one. How do I want to do it? I got 2 different ways I could do it. I could say x is greater than 2. I could say that.
2 is less than,
that-
versus less than.
I'm just going to write it this way. 2, comma, infinity, like this. Okay? Any one of those are fine. I understand them. If you're using them, I hope you understand them too. Okay, test values. Derek, what number are you going to put in here?
0.
No.
-3.
0 isn't less than -2, Derek.
Oh, my bad. Yeah.
Yeah.
Duh.
Okay, what are you going to put here?
-1.
And here?
1.
You don't have a lot of choices. You have an infinite number of choices, but there's only one good one.
Yeah.
4. And over here?
4.
Okay. Now, the sign. Let's see. Okay, here we go. Put this in here, and that's going to be negative,
Yeah.
right? And I put this in here, and this is going to be
Positive.
Yeah.
Why did you say positive so quick, Greg?
That's 4.
Okay, 9 minus 4. So this is positive. So this is going to be,
Negative.
okay? He answered it so quickly, I was wanting to know if you all caught on to that. Okay, now how about this one?
Positive.
Negative.
Positive.
Negative.
Okay, here we go. We're going to put a negative. That's going to be negative. Okay, now if we put this in here, it's this, the cubed root of a -5. Okay, here's an example. The cubed root of a -8 is
-2.
-2,
Why is it negative?
right? Fine?
Why is it negative?
Oh, what? Because, oh, I'm sorry. It's a -3. -3. Okay, sorry about that. So this is going to be positive, and this one's going to be,
Negative.
why?
Because of the bottom.
If you put in a 1,
You get -3.
say, just a second. Yes, okay, this is going to be negative,
Negative.
and this one's going to be
Positive.
positive.
Yep.
Okay, positive up here, and that turns into, just a second. Oh, that's 16, so that's, yeah, all positives. Okay, so this is decreasing, this is increasing, decreasing,
Increase.
increasing, and therefore this is going to be decreasing, increasing, so minimum. And this is increasing, decreasing, max. So it doesn't really take rocket science to figure these out if you just do this way. And this is a minimum. Okay? Now, let me just show you that with Desmos a minute. It might take me just a moment. I think it's right up here. Okay, this is the first one. See the first one here? I did blow the thing up because it wasn't so quick to make that thing. See, here's your 3rd-degree equation. And here's the maximum point. And that happens to occur at 1, 2, 2 here. And on this side, you see a 3. And down here. See, so, you know, we do all this hard work, and it's so easy just looking at it, okay? But it's the interpretation and see what's happening so you can interpret it in a business problems, physics problems, and others. Yes?
So when we're doing like these on the assignment, can we just graph it or not?
No.
Or do we need to do it?
My suggestion is do it this way first and then check your work.
Okay.
The reason is if you look at this first, it becomes too easy and you probably will mess it up, and I might say you can't use your calculators or computers.
Eric, don't you dare.
Okay? Get the point?
Yeah.
I think, okay, also, if I fail in terms of teaching an area was not doing enough without computing. I love to use computers and calculators, but to make certain you are doing the thinking process. And as I see this class going, I think it's going pretty well. Yes?
So this chart then is the answer?
Yes. Mm-hmm. And then when you check the back of the book on those problems, you'll have to read carefully because it's kind of hard to figure out all that stuff. And when it's there, it's so easy. It's just all right in that little table. Okay? Okay, now here's the other one. And there it is, but I'll just go back to normal. See, there it is. Isn't that cool? See those little cusps over here?
Yeah.
And another thing about this, what happens? What would this thing look like if this were flipped over the x-axis? It almost, yeah, or I was, yeah, no, I wasn't thinking the middle. Oh, I didn't make it clear. It would look like an M that way. Okay, I was just thinking of this part over here, and I didn't make that clear. It almost looks like a parabola. And I'm not certain if it is. I don't know the curve of this line. I don't think this is a straight line.
No.
I think that sucker's curving just a little bit. Now, is that curving
Zoom out
at the
really
same
far.
rate as this one?
Mister.
I'm not totally sure.
Zoom out really far and you can see if it's curving.
Yeah, you can?
Well, you should be able to see if it's a lot larger scale.
Okay. Why not take a look?
Awesome. Look straight or you gotta zoom in.
Oh, it's curving.
It's
It's curving the other way, though.
It's a parade.
Okay. Now,
It was curving like this.
It goes like this.
That's the way it's supposed to. Yeah.
oh, okay. Now, a few more things for today. You see what happens here. Does anybody have any questions about doing problems 26 and 29?
Okay, we just have the last 5 minutes.
What was that?
Can we just relax the last 5 minutes of class?
Are you kidding?
Thanks, Mr. Can you do one of them?
No. Let me just run through a couple more things with you, because some of you are not going to be here tomorrow. And I will redo some of this stuff tomorrow with you. Okay. The definition of concavity. Okay. Very important stuff that's happening here. Look at what it says. Let f be a differentiable on the open interval AB if f prime is increasing on I, like that AB stuff up here, because I use both here, then f is concave upward. That means this. Here is the graph of my this thing here. It's increasing. It's not going straight. It's increasing like this. See that? That's concaved up. Okay. Now the second one, if it's decreasing, it's like this. Okay. Also, those of you who are not going to be here tomorrow, make certain, I think it's on page 241. It summarizes the chapter in beautiful form with 9, I think there are 9 little boxes. You might even like to start there. Look at those and then look at them again. Okay?
241.
Now, 241. Okay, that's concavity. Lucas.
Yes.
That isn't the first time. You know that. I've seen it quite. Okay, now, look what it says here. Let f be continuous at C. Are you with me? Okay, and f changes concavity at C. So what? What does that mean? Okay? It goes like this. See? And then it comes up like this. Okay, that could be a 0. First derivative, it could be a critical point. But this is concave down and that's concave up. You with me?
Yeah.
So you get that idea. Now notice this is a definition and this is a definition. And in your book, I think these are both in one package. Okay? Now, here's a concavity test. And we'll get into that a little bit more tomorrow. Let f be a function whose second derivative, we haven't looked at a second derivative before.
Yeah, we have to.
Well, yes, a little. Okay? I take that back. Okay, now look at here. Here the first derivative is bending. It's changing. You have a change making a change. Meaning, I'm going down the road changing positions by going 50 miles an hour, and all of a sudden I hit my accelerator and I go faster. Okay? You're changing your velocity. Velocity is a change, so you're changing it. Okay? That's what this is all about. And it says if the second derivative is greater than 0 anywhere for all x in that interval, then f is concave upward. And this is how I usually draw that. If it's greater than